Okay, in this video, we come to the end of our discussion on proportions. So the first part of the notes recounts where we've been. And when we first part of the chapter, we asked, are two quantities related? Are they connected somehow? And one of the first questions we were asked is, does a table show a proportion? You were given tables like this. We have miles and over hours, right? And we were asked, does this relationship show a proportion? And what we had to do is we just had to compare the y to the x, and we did that. 120 over 2 is 60, and 180 over 3 was 60, and 300 over 5 is 60. So because we had a constant ratio for all the data, we said yes, this relation shows a proportion. So we had it with numbers, and then we go further and we graph things. Does the graph show a proportion? And what we did, we plotted some points often, we drew a line, and we looked. In this case, again, the answer is yes. Why? Because we had a straight line. The data can be lined up in a straight line, and there's two parts to this, and it went through 0, 0, or the origin went through. If it met those two criteria, we could say that the graph is a proportion. So whether we were asking, does the table or the graph or the relationship show a proportion, we only had two possible answers, yes or no. And then you were asked, how do you know? Well, now we move on and we want to know, well, how can we describe two quantities that are related? Like if we look back here, we see that the constant ratio is 60 over 1. So for every 1 hour driving, we might say this for our above example, for every 1 hour driving, you cover 60 miles. And we have different names for these things. Let me write it this way: 60 miles in 1 hour. We called it the constant rate of change. Because it's out of 1 hour, we called it the unit rate. And most recently, we found that we described it in terms of slope. That is, the change in y over the change in x. So we was 120 miles in 2 hours, 60 miles an hour. That's the slope of this line. Okay, now we're moving on, though. How can we describe two related quantities? Well, if you want to do it with a table, we start here and we know that we can see here that this table, there seems to be a change of 1 at each step. I'm adding 1. Where at the bottom, I'm adding 2. Well, this table would just go on forever. And this is an example of using numbers. We talked about how, I mean to nag you that we want to see things with numbers, algebra, graphs, and I'm adding nag W. We also want to do it in words. So the table is like numbers here, right? So if I call this this is like my n here. But this table, does it show everything for all possible combinations? No, the table will just go on and on and on and on. And no one wants to write a table that big. If we looked at the graph, we could plot a few points here, but this line, it goes on and on and on and on and on, and the graph would get rather unwieldy if you wanted to find out how far he went in, say, 200 hours. So that's kind of a mess. We could also say it in words. The words is kind of unique for every 1 hour. In this case, I'm using this case here. I'm sorry, I should have gone over this. For every hour, you can see it costs $2. So every 1 hour costs $2. So this thing has a constant ratio of 2 over 1. If I go over 1, I go up 2. If I go over 1, I go up 2. Well, when you have two quantities, like cost and hours, x and y, cost and hours, that have a constant ratio, like this does here, that relationship has a particular name. That relationship is called a direct variation. And this is kind of the heart of what we're getting at today. So this constant ratio is the y over the x. And for example here of hours and cost was on top and hours is on the bottom. And for any point along the line, the ratio is the same. It's a constant. And that constant ratio, they indicate with this letter K. It's just, I used K because that's what's in your textbook. And we say that y varies directly with x when we have a constant ratio. And there's two ways it's written. You'll see it written this way. So we have a constant ratio. That means when I put any y value over any x value at any point, I always get the same number, the same value. The other way it's written is this way, y equals kx. If I multiply both sides by x, you can see in this example, the x's will drop out, and I'll have y equal kx. So this is my direct variation equation right here. Let's be clear on that, because we're going to use this. Direct variation equation. So any relationship that's a direct variation, we can write this way. It is one form of a linear equation, where k is my constant of variation, and x and y are points along the graph. And in the world of mathematics, sometimes they've got multiple names for same things. So k, it is a constant ratio. We saw that just looking at the points here. But it also has other names. The constant of variation is a name. The constant of proportionality is another name. But we also know it from our previous work. It's also the unit rate. Right? It's also the slope of the line when the line goes through 0, 0. And it also has, sometimes people call it the common ratio. That's what we had earlier. But what it's telling us is along the line, how far I go to the left and how far I go up from one point of line to another is always going to stay the same.